Okay, now we're going to talk about partial sums of geometric sequences. So partial sum is when you add so many of the first few terms in the sequence. And we denote that by Sn. Now for a geometric sequence, there is a particular formula that we want to use to find the partial sum of the first n terms. And that formula is where you take a1, which is your first term, and you multiply it by the fraction where the numerator is 1 minus r to the nth over 1 minus r, where r is your common ratio. So in example 1, it says express the geometric sum using summation notation. We are going to use both methods so we can practice. We're going to use summation notation and we're going to use the formula. So if you notice, there are no missing terms here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we want to add up those first 9 terms. So we want to find S9. So we need to take the first term, which is 1, times 1 minus r to the n. Now r in this case is 4 because to get from one term to the next term, we have to multiply by 4. So I'm going to have 4 to the power of n, which in this case n is 9 because we're trying to add the first 9 terms, over 1 minus 4. So in my calculator, I'm going to put 1 times 1 minus 4 to the 9th in the numerator, 1 minus 4 in the denominator, making sure that you put parentheses around the top and the bottom when you put it in on your calculator. And when you do that, you are going to get 87,381. Now, to use the summation notation, we are going to start at n equals 1, and we're going to add up the first 9 terms. So we're going to start at 1 and stop at 9. And then the geometric sequence, the nth term, just as a refresher, an is equal to a1r to the n minus 1. So we have to put in our nth term so that it can generate each of those terms and add them up. So my a1 is 1 times r is 4 to the power of n minus 1. Now when you put this in on your calculator, we have 2 sets of parentheses. One that goes around the entire sequence, and then one that goes around our value of r. So make sure you put parentheses in the right places when you put that in on your calculator. When you do that, you should get the same answer, 87,381. For example 2, we're going to do the same thing. We're going to find the sum, and we're going to do it using the summation notation and the formula. However, this is a little bit different than example 1 because notice we have missing terms. So we don't know if 1 over 256 is the 10th term, the 12th term, the 5th term. We don't know. So first we have to figure out what term that is. So if you notice, let's find the nth term. Our first term is 1/4. Our value of r would have to be -1/2. To get from one term to the next, I would keep multiplying by -1/2. So here is our nth term. So using a little guess and check and plugging in some different values of n, we're going to find that 1 over 256 is when n is 7. So a7 is 1 over 256. So now we can use our formula. So we're going to find the first 7 terms and add them up. So we're going to find S7. So we're going to take the first term, which is 1/4, and take 1 minus r to the 7th, and r in this case is -1/2. and we're going to divide by 1 minus r. So making sure that you put parentheses around the top and around the bottom, and look, we have two different sets of parentheses here, so make sure you put all the parentheses in the correct way in on your calculator, and you should get 43 over 256. Now, if we do this using summation notation, we want to go from 1 to 7. We want to put in our general form or our nth term so it can generate each term and add it up. So my first term is 1/4. Then I have r, which is -1/2 to the power of n minus 1. Making sure that we put both sets of parentheses in there. We have the parentheses that's around our r, which is -1/2, and then parentheses around the whole nth term. When we do that, we're still going to get 43 over 256. So no matter how you do it, you should still get the same answer. Just be careful of making sure you put your parentheses in the right place. And it doesn't take that long to do it both ways, so it's probably a good idea that you do work it both ways so you can check your answer. Okay, example 3 says find S6 for the geometric series. So I need to take the first term, which is 0.8, and multiply it by 1 minus r to the 6th. R is going to have to be -5 because -5 is what I multiply by to get each of the next terms. And then I'm going to divide that by 1 minus r. So when I put that in on my calculator, I'm going to get -2083.2. Now if we use the other method, which is the summation notation, I'm going to start at n equals 1, and I'm going to go to 6 because I'm trying to add up the first 6 terms. And now I have to put in my nth term so it can generate each term and add it up. So my first term is 0.8. My value of r is -5, and I'm going to put that to the power of n minus 1. When you put this in on your calculator, make sure you put parentheses around the entire sequence and then parentheses around the -5. When you do that, you should also get -2083.2. One other thing to note is that the variable button on your calculator uses X. So even though I'm writing down n's on here on my paper, you should be using your variable button and it will be coming up as X's on your calculator.